Okay, so the last two problems in 12.1, the reason why they're going to go so quick is really it has to deal with reading tables or reading graphs and then getting your information from there. And so the first example about Andre's investments is where we're going to have a table of information, and then they want you to make a circle graph. Now, a circle graph is what we would also call like a pie graph, where it looks like you have a pie and it's cut up into a whole bunch of pieces, and those pieces represent usually a percentage of the total pie. And so we could do this based on what is your favorite style of food. You guys could tell me what's your favorite style of food, like American, Italian, Chinese, all that kind of stuff. And I could make a circle graph where the whole graph is everybody that's in this class is 100%. And then let's say 50% of you say Italian is your favorite. Then I would cut the pie in half and 50% would represent Italian. And I could keep making the slices based on the percentages of the class that likes a specific food. And so for this problem, we have Andre's investment, and here's all of his different investments. He has stocks and bonds, cash, and metals, and it tells you the percentage of his total investment. So 55% of his investments in stocks, 20s in bonds, 15% in cash, and 10% is in metals. Now, on Pearson, they're going to ask you to make a circle graph. What they ask you to do is pick the circle graph that matches the data that they give you. And so I'm not going to draw a circle graph. I'm going to show you what it looks like. So if we made a circle graph based on his investment portfolio, what we would have is what looks like here, where just a little over 50% of our pie, or our circle, is made up of stocks. 20% is bonds, 15% is cash, and 10% is metals. So you should be able to read either of these, either in table form or in a circle graph form, and answer some questions. That's really more what the homework problems are like, is where they actually give you one or both of these pieces, and then they ask you, where is the majority of Andre's investments? Or where does he have half as much investments compared to bonds and things like that? And so some of 12.1 is going to simply be reading the information that they give you. Can you read a pie graph? Can you read a table? Can you read a bar graph? And so some of that just takes some practice. And if you discover that you struggle with bar graphs, or you struggle with moving data from a table and then translating that into a pie graph and reading it off of there, then when you come to a problem like that on the homework, attempt it. If you get it, great. If you don't, that's fine. Either way, you can always do a similar exercise to regenerate that problem and thus get some extra practice. And so I highly recommend that on any type of a problem that is giving you some trouble or one that you want extra work on. So that's how you do a pie graph or a circle graph. Again, you are not going to be asked to actually physically draw a circle graph and color it in and all that jazz. Basically, you need to be able to translate it and make it make sense. The last problem that was in 12.1 had to do with a line graph. Reading a line graph and answering some questions. It says, answer the following questions based on the figure 8. The figure 8 is all about the antibiotic resistance of salmonella infections in humans. And there's two different pieces of data here. We have this top, I say top because it lives on top most of the time, which is resistance to the cefrexitone. I am not a science person, so that's a good guess. And then we have this one that lives more in the bottom, which is resistance or partial resistance to ciprofloxacin. If any of you are math or science people, I'm sorry. I am not very good with those names. Basically, we have two different types of resistance. We have Ceph up here at top, and we have CIP down here at the bottom. And it shows you that over the years, because the years are down here in the bottom, the percentage of the resistance. And so it tells you how often people were found to be resistant to these different strains of salmonella. That's what this table, or that's what this graph is showing us. And so with this information, they're going to ask us some questions. A says, what time frame is reflected in the figure? So what are the years represented in this table? Who wants to take a stab? Great stab. That's a great one. 1996, that's our very first year listed over here, and notice that lines up with our 0. And then if we keep going over, yeah, we jump every 2 years, but then we have this little tick mark here that's not spaced the same, and it's not labeled the same. So yes, 2011. Perfect. In which years did the resistance to SIP, so SIP, let me show you, SIP is this one. Try and color it. So this is SIP, the blue one, or now the markered one. In which years was the resistance to SIP greater than the resistance to SEF? So we have to be able to read and interpret the graph so we can figure out what years the blue or the marker line, the resistance was greater than the black line. We're just going to list a bunch of years. Okay. Perfect. So the way that you read a graph is if it says which one, when is SIF greater than, that means when is it going to be higher than. And so if we look at the blue, it's over the black line here at 96, 97, and 98, just like you said. 1996, 1997, 1998. And then if we look after that, we start staying below the black line, up until right here again. Right here at 2011. So that's how we're going to read this information. The last question says, over this time span, so from 1996 to 2011, what was the highest resistance to SEF, so that's the black line, achieved, and when did it occur? So when did the SEF triaxon, the black line, what is its highest value and when did it occur? Well, if I'm looking at the graph, I'm going to look at where's the highest point on my black line. And actually, look, it's right here. It kind of flattens out between this dot and this dot. So this dot happened in 2002. And then this dot kind of falls in between the 2002 and 2004 dot. So that'd be 2002, 2003 is when it happens. And then if I look over at my y-axis, notice it falls pretty much right in the middle of 4 and 5. These are percentages to resistance. So that means it hit 4.5% of the population, and it did this in the year 2002 to 2003. It actually spanned a whole year based on this information. It didn't just touch it and come back. It actually stayed at that level for a solid year.